Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, if you remember, then in the previous lectures, we had been learning different properties of the real numbers. But now in the present exercise, we will learn to prove the different properties of complex numbers. If you don't know anything about the complex numbers, or you are not aware to the complex numbers, that what are these complex numbers, then you should watch my other lectures which have been recorded for the introduction to the complex numbers. So you must watch the introduction to the complex numbers for the more better learning of this chapter. Anyhow, let's proceed to the first question of exercise 1.2. And according to that first question, we have been asked to verify the addition properties of the complex numbers. So what are the addition properties of the complex numbers? So we'll proceed toward the solution, and there are different properties of the complex numbers. Means addition property, different addition properties of the complex numbers, and these properties include, the first one is the additive identity property. The second is additive inverse property of the complex numbers. These names are resembling to the properties of the real numbers. Third is the closure property of addition of the complex numbers. And fourth property is the commutative property of addition of complex numbers, while fifth property is the associative property of addition of complex numbers. Now we will prove all of these properties one by one. So at first we have to see the additive identity property of the complex numbers. So as far as the additive identity problem is concerned, so additive identity means a certain quantity, a certain complex number which added to a certain complex number, then the main number remains the same after its manipulation. So for example, let us see that we are having a certain number that is, let C is equal to, let C is equal to A plus B iota. This is actually belonging to the complex numbers. So if we add 0 plus 0 iota, 0 plus 0 iota into it, into the complex number, given the complex number, then what happens? That if you are going to add A plus B, add 0 plus 0 iota into A plus B iota. So A plus B iota plus 0 plus 0 iota. Then what will happen? That real numbers will be added to each other. So this will become A plus 0 plus B iota plus 0 iota. Or this will become A plus 0 is equal to, because this is the property of the real numbers, additive identity of the real numbers. So A plus 0 is equal to A plus B iota plus 0 iota is actually, we can take iota as common. So B plus 0 is left here. So you have got A plus B, A plus, and since B and 0 are also the real numbers, and so according to the property of the real numbers, we have B plus 0 is equal to B. So B and iota is left. Therefore, we may say that the additive identity property is satisfied for the complex numbers as well. Previous to it, it was satisfied for the real numbers only, but now it is satisfied for the complex numbers as well. So additive identity property is satisfied for the complex numbers. So hence additive identity property is satisfied for complex numbers. So this was the proof of the additive identity property for the complex numbers. Now we have to look for the other property. The other property is the additive inverse of complex numbers. So let us consider a complex number C. Let we are having a complex number C as a plus b iota, or you may also write it as inside the brackets as in the form of pair as a comma b. So a comma b means a plus b iota. This was already told to you. And so if we add minus a minus b iota, then so a plus b iota is being added with minus a as you may also write it as a plus b iota plus into minus a minus b iota. It's not compulsory to use these brackets symbols for this. You may also write directly it in the form of a plus b iota or minus a minus b iota, so on. Any of minus a minus b iota, or you may write it in the other form, in the proper arrangement as a minus a plus b iota minus b iota. And now you can understand that these a and minus a have been cancelled with each other, while plus b iota and minus b iota have been cancelled with each other. Or you may add another step as well. If you want, that will be more better, that if you are using another step, and that step is that if you are taking that a minus a has cancelled, so this is 0, plus b iota is common. Why I'm adding this step? Because we are still unaware, or we have not still proved the property of the ideal imaginary numbers, that they can be cancelled as well. That's why I'm using this thing. So because we are aware to the real numbers only, that's why, because b is the real, b can be cancelled, and that's why we are using it. So you may write it as b minus b. So b minus b are real numbers, b and b. Therefore, these will be cancelled, and you are left with, so 0 plus b minus b is 0. So this is 0 iota. So 0 plus 0 iota is the additive identity. Basically, it is the additive identity because it has resulted in the addition that two different quantities were added to each other, and additive identity has been produced. Therefore, the two quantities which have been added to each other, these are the additive inverse of each other. It means that minus a iota minus a minus b iota, that is, or you may also write it as, or a comma b, minus a comma minus b is the additive inverse of what thing? Basic was a plus b iota, or that may also be written as in the form of a pair. So ab in the form of the pair. Therefore, you may say that A minus B iota, A plus B iota is the additive inverse of A minus B iota, and minus A minus B iota is the additive inverse of A plus B iota. Both are additive inverses of each other. Both are additive inverses of each other. So this was the solution for the second property, which is the property of the additive inverse of the complex number. Now we will be proceeding towards the third property of the complex number, that is the closure property of addition of complex numbers. So what's meant by this property? That if you are going to add two or more complex numbers to each other, then the resultant new number will also be a complex number. So that has been closed, means it is not going outside of the complex numbers, but it will still remain the complex number if you are adding two or more complex numbers, whatever they are having, any quantities. So for this purpose, we have to consider that for all, what is that we are having C1. C1 is a number, complex number we are considering, which is A1 plus B1 iota, while we are also considering another complex number, which is C2, and C2 is equal to A2 plus B2 iota. So now we are going to add these numbers so that we can check that either the sum of these complex numbers is either a complex number or not a complex number. So we have C1 plus C2, which is equal to A1 plus B1 iota, and next is C2 is A2 plus B2 iota. On splitting the brackets, we get A1 plus B1 iota plus A2 plus B2 iota without brackets now. So now we'll be making the arrangement of the real numbers, and that is the A1 plus A2. These are the real numbers. While the next is B1 iota plus B2 iota can be rearranged. So in this form, we have written that the real numbers are written prior to the imaginary numbers. Now A1 plus A2 and B1 plus B2, and now because since they are having iota as common for both of these, so B1 plus B2, B1 iota plus B2 can be written, and B2 iota can be written as B1 plus B2 into iota, because iota has been taken common in both of these. So this is the situation. Now if you examine it or analyze it, you find that A1 plus A2 means real plus real, and we had already found that real plus real is always a real number. And also the same is the case with the B1 plus B2, because B1 and B2 are basically the real numbers which have been combined to this iota. That's why, as far as their nature is concerned, they are real, and so B1 plus B2 are forming a real number, which is when it is combined to the iota, it is called as the imaginary number. So this is also the portion which is comprising of the complex number. So this is a new complex number, which is A1 plus A2 plus B1 plus B2 of whole iota. This is a new complex number, and so it is belonging to the complex numbers. So it is the part of the complex numbers. Therefore, we may say that C1 plus C2, that means the sum of the two complex numbers, is equal to is the subset of the complex numbers. Means it is not going outside of this complex numbers. Therefore, we may say that hence sum of all complex numbers satisfies the properties of, what is that? The closure property of complex numbers. So closure property is proved here. Now we have to look for the fourth property, and that is the commutative property of addition of complex numbers. commutative property of addition of complex numbers. So what is this property? That if you interchange the positions of each, the first complex number and second complex number, which are going to be added with each other, then the result same. For example, the first is C1 and the second is C2, and if you get the result of C1 plus C2, or you are getting the result of C2 plus C1, means you are changing the arrangement, the result is same. So we have to prove this property. So let us consider that we are having two complex numbers. First is A1 plus A1, C1 is equal to A1 plus B1 iota, while the second is C2 is equal to A2 plus B2 iota. And so then what will happen, that if we are going to add C1 plus C2, that means C1 and C2 are going to be added, then it means that A1 plus B1 iota and A2 and B plus B2 iota are going to be added with each other. And so on splitting the brackets, you get this thing, A1 plus B1 iota plus A2 plus B2 iota. After it, you are going to rearrange them, and so it will become A1 plus A2, means the real numbers are being written on one side, while B1 iota plus B2 iota means imaginary numbers are written on the other side. So again, making them proper arrangements, that A1 plus A2, since they are real numbers, so we are going to write them inside the brackets of the real part. So this is the real part, A1 plus A2 is the real part of the new complex number, while the B1 iota and B2 iota have iota in common in between them. So these may be written as B1 plus B2 into iota. So this is a new complex number, and now we have to mark it, and we are going to name it as equation 1. So this is the equation 1, means the result of C1 plus C2 has been taken, and this is going to be named as the equation number 1. Now we will be doing, for at the current time we have done C1 plus C2, and now we will be doing for C2 plus C1. So let's write that C2 plus C1. So we are, if we put the values in the same manner which we have already done, so it will become A1 plus B2, A2 plus B2 iota, because we are taking C2 at first and C1 as the second. So A1 plus B1 iota, and then so A2 plus B2 iota, and then A1 plus B1 iota are going to be added with each other. So on splitting the bracket, you get this thing, that A2 plus B2 iota plus A1 plus B1 iota. So on arrangement of the real numbers and imaginary numbers, so these are two real numbers which are A1 plus A2, and then imaginary numbers are B1 iota plus B2 iota have been written on the other side. So now real numbers will be packed with each other. So A1 plus A2 have been packed with each other inside the bracket, while the B1 iota and B2 iota have the common iota in between them. So remaining are B1 plus B2 inside the brackets, while iota has been taken as common outside of this. So this is the new real number, and we are going to, because this is the result of C2 plus C1, now, so this is going to be marked as equation 2. If we do the comparison of these two equations, that equation 1 is the resulting into A1 plus A2 plus B1 plus B2 of iota, while equation 2 is also saying the same thing, that A1 plus A2 plus B1 plus B2 of iota. So both are having the same results, means C1 plus C2, the result of the C1 plus C2, and result of the other complex numbers, that when they are interchanged with each other, so C2 plus C1 is also similar. Therefore, we may say that comparing, if we are comparing equation 1 and 2, we find that C1 plus C2 means the sum of the two complex numbers of the first complex number and second is equal to the sum of the two complex numbers in the other arrangement, means C2 plus C1. So C1 plus C2 is equal to C2 plus C1. Hence, our commutative property of the addition of complex numbers has been proved. Now we have to use the procedure for the last property, fifth property, and that is the associative property of addition of the complex numbers. So we are concerned with the associative property of addition of complex numbers. So what's about this property? That according to this property, we had already got the concept on the numbers. that associative meant that if we had three real numbers, then the sum of the arrangement of the sum of the three real numbers doesn't matter. Means if you are going to add first number into second number and then that result into the third number, or you are going to add first at first you're going to add the second last two numbers, and then add the result to the first number, then the results will always be same. Now let's see that what's happening in the complex numbers. Let's consider that we are having three complex numbers. That first is a1 plus b1 iota, second is a2 plus ba2 iota, while third is c3 is a3 plus b3 iota, and we have to add them. And how we are going to add them? Then let us consider that at first the c1 plus c2 are inside the brackets and c3 is outside of the bracket. It means that at first we have to add c1 and c2 and their result will be added to c3. Anyhow, so on substituting their values, so this is we are taking c1 and c2 inside of the main brackets. That's why I've written c1 and c2, means a1 plus b1 iota and a2 plus b2 iota. The sum of these will be written inside the main brackets, while c3 means a3 plus b3 iota is outside of these brackets. Now at first you have to add, because the brackets are compelling these two first complex numbers to be added with each other. Therefore, let's split the inside brackets, the internal brackets of the two complex numbers. Outer brackets will not be split now, but we are making the arrangement inside the brackets. So a1 plus a2 and plus b1 plus b2 of iota. We have already learned this property in the previous properties that in which we had been studying the arrangement of these properties. Anyhow, then last is a3 plus b3 iota. So now, so here is a new complex number a1 plus b2, a1 plus a2 and b1 plus b2 of iota. So now we'll be writing in this sense that we are going to split the outer brackets. Just now we have splitted the outer brackets. We have done nothing here, but outer brackets have been splitted. And now we can change the arrangement, that a1 plus a2 will be taken with the a3, that a3 is coming toward there, because all of the a1, a2, a3 are the real numbers, therefore they are coming towards each other, while the b1, b2, b3 are coming at another side. So, and iota is common in all of these, that's why we have taken iota as common from b1, b2, b3. So now again we'll be changing the arrangement inside, because we had already proved the associative law. So according to the associative law of the real numbers, all of these real numbers, these numbers can change their arrangements. Therefore, a1 plus a2 plus a3 can have the arrangement of a1 plus a2 plus a3. So brackets can travel here. While similarly the case with the b1, b2, b3, because if written except the iota, then they are real numbers if they are not written with iota. So these will be following the real numbers properties when written when being treated with each other. So, and hence, so b1 plus b2 plus b3. So arrangement of the brackets have been changed due to the associative property of the real numbers. Now, so we have seen here that c1 plus c2 plus c3 can be written in this form. So we have done this thing. So we are just again splitting the brackets of the iota. Iota bracket has been splitted now. So now we are taking a1 plus b1 iota with each other, while a2 plus a3 and b2 plus b3 of iota, they are going with each other. So you know that here a1 plus b1 iota, this is basically c1. means first complex number which we had supposed, while plus sign is next, so plus is being written here. Next is because whatever is written is inside the main brackets, so main brackets is being used here, so we'll be using the main brackets here. And inside the brackets this is a2 plus a3 plus b2 plus b3 of iota. So iota brackets have been split now, so we are splitting the iota brackets here. Now, so this is C1 plus, now we have to change the arrangements here, and so just we have changed the arrangements. Now you see here that that a2 plus b2 iota, a2 plus b2 iota is actually C2, means complex number which we had supposed, and plus, then you have to use the plus, and then next complex number is a3 plus b3 iota, which is C3. Basically this is C3. So, and you can see here that we have changed the arrangement here, that at first we had been solving for the C1 plus C2 and then adding it to C3, but now at here we have got the result that which is C1 plus C2 plus C3, which are being added with each other at first. So hence we can say that associative property of the addition of complex numbers has been satisfied. Dear students, if you face any issues regarding the understanding of this lecture, then please write your issues in the comments section so that I can respond accordingly. Thank you very much.